Story is not the same as we get in the second and third and so on, especially for skyscrapers or whatever height or tall buildings. Yeah, this is a 2D map. It can be a raster map or a vector map, doesn't matter, it's 2D. We can add some additional information, which is not geometric information, it's dramatic information, but it anyway helps very much better understanding what's there and how it behaves. We can see it in a 3D, it's nothing new. And on a 3D we can add the noise sources, we can elevate the structures of the building. These buildings are 3D, so they have correct facade material, and as well as the terrain around has to be initiated with the correct material and so on. And okay, we can go calculate the noise values. How is it done? Basically performing the steps we saw before with the noise spheres and so on. It takes a very long time, but there is a shortcut, which is, in this case, it's pressing the magic button here. No, actually, I don't want you to see it as a black box, but it's all based on the algorithms we saw before. I can ask them to render the contour volumes. So I want to see how is the volume enclosing all the 3D points with, say, 80 dBs. Then I wanted the 70 dBs or 65 and so on. And just I want to do that and go on. This is the 70 dB iso contour of the surface. As well, 65 and so on. I can assess the value and visualize them the way I want. Of course, this is a fully 3D model for what the base concern the base, so it's X, Y, Z. I'm adding a fourth dimension, which is in this case, it's a parametric dimension, which is the noise value. I'm adding also some colors to better understand. It's not the dimension by itself, but it's useful. Since it's fully 3D or plus model, I can actually fly around it, see it from any point of perspective, so any point of view from any perspective, and so on. Okay, the fourth part, which is nearly for the conclusion here, is that what can I derive from these two experiences we had? The one having long-term measurements with the real-time feedback, and the second one being this ability to render it in multiple dimensions. Well, I can melt the two, not melt, it's not the right way, but right word, but fuse the two things and obtain something more, which is something more of the real-time monitoring, and it's something more as well of the simple 4D visualization. Let's say it's not a 5-dimension. If I had time, someone could state it's 5-dimension, but let's be conservative and let's call it 4.5D. All right. Okay. I hope that the movie will see. So we are able to see in real time what's happening in our area, and the feedback from the sound level meters in these points here give a constant and in real-time calibration of the model, which will be able to visualize and to query, because it's, I forgot to mention it, it's of course all queryable, so I can query any XYZ point or a point and click and ask how much noise do I get here in LAQ or in LACQ or whatever. It's not been done for octaves now, but I think it's a little bit too early for doing real-time multidimensional octave. I think it will be a little bit complicated. But in this case, I think this kind of visualization might be useful. So these are the conclusions, but also a request for comments. So I really ask you to tell me what you think about this. Is it something useful for you? Would it be something useful for you if it had to be applied on a larger scale? And If yes, do you think it will have the same impact that during the 80s the 2D maps or the 2D contours had on the population or understanding of social community, noise, and so on? So what we saw here was implementation of real-time monitor noise monitoring, physically based 3D noise monitoring, and 4D plus, let's say. All this why? Because to manage, and we are in some way managers, we need to know what's on field, so we need to perform measurements. Okay. Okay, that's it. Thank you.
We do have time for questions. So, right.
How do you see these capabilities applied to the kind of situation, the community problems and concerns that were illustrated in the previous presentation?
Yes, I think this can be a breakthrough in the way we present noise to communities, but we have to be careful, in my opinion, because if we show something like this, back fast enough, something like this to someone in the community, they say, oh, what's that all over my house? Or I don't want to see that. So it can be effective, but probably not from the beginning. We first have to find out a way to tell people what it means. Exactly as we had to find out a way to tell people how maps are, because not everyone is capable to read a map, and much more not to understand what a contour line is. Someone said to me once, hey, what's the line cut in my house? Okay. It's a contour line, it's not really there. These are experiences, as I said, that come from a gas emission dispersion background. In that case, I think it's more comprehensible what they mean, because they are similar bubbles to this. They are, of course, much more affected by wind speed and wind direction and so on. But basically, there are bubbles like this, and you can tell them, okay, this is a bubble of enclosing all the points which are above a given risk level. And it's more comprehensible, I think. In this case, I think probably with a small presentation like this or something like that, it could be feasible to let people understand how this visualization will render their actual situation on existing or on highways to be built again.
Another question?
Yes. Have you thought about applying a similar approach to large construction projects or construction noise?
Yes. I repeat the question. The question is if this approach is, if we go to apply this approach to construction noise. Of course, it is not related to highways. We use it for example, for airport areas or whatever. It's basically a visualization, so we can, depending on the data we feed into, of course, it has to be with a given accuracy, but not just any data. We can visualize it or we can analyze it. Of course, this is only a PowerPoint presentation. I don't have the full workstation here, but it's possible, of course, to go through the model and have a cutting plane and see how these volumes are cut and create contour lines in cross section or also in horizontal planes, basically getting back to the contour lines. And so it's also a possibility there, definitely.
Thank you, Douglas. I'd like to thank all of our speakers.